Hello everybody, welcome to part 11 of the Openthread 101 series, and in this part I will show you how to run the Openthread border router on your Linux machine. So in this case I'm using an Ubuntu 2204 machine. So we will just run the border router on this machine and connect CLI device to the network, and we will prove it by just pinging an 8.8.8 DNS server. It's from Google. So if you don't know what the Openthread border router is, so far we have been working with the Openthread network, but we were not able to, so we were able to talk between the devices within the network, but we were not able to talk something outside of this network. And one of the benefit of Thread is that since it's an IP version 6 based network protocol or networking technology, it's basically the same technology as being used in any network or in general on the internet, and you can basically send packets from this network all the way to the cloud, and that's really one of the advantage. So let's start. So in this case we would use a Docker based workflow. In our case, this is just I guess useful for developing your own system or just for development purposes. I haven't used it in production, but maybe you can use it in production as well if your gateways are some kind of Docker based systems, like Balena OS or something like that. Then maybe you can use this setup to also have your gateway work as OTBR and be able to update everything there as well. But that's for future. So if you are interested in basically creating an IoT gateway using Balena OS, and that should work as a Openthread border router, and you can host some other applications there as well, then let me know, and I can then do a video about that as well. So in this case, what we need is for our system to work as a border router, we need some device that lets us connect to the Thread network, and in this case we would have an NRF 52840 dongle that we would use. And so let's just start with the practical part, but I would just go through the step. And then first we prepare the dongle, then we prepare our machine or the Linux machine that we have, and then we would just basically create a network, or in this case we can also join an existing network, because the border router allows you to scan for existing network and you can join a network as well. So we would just join an existing network, and then we would use the CLI that we've been using in the previous parts to ping 8.8.8, and then this would tell us that okay, our network is our border router is working and we can reach the cloud. So let's get started. So what I would do is open the NRF Connect desktop application. So it's in desktop with me. It's on desktop. So we would just run the NRF Connect app image, and hopefully it can run this way. Yeah. Then let's open the programmer, and let's just launch it anyway. And currently we don't have any device. So we have one device 1, which is if you remember from the last videos, is one of the CLI devices. So this programmer allows you to flash devices that are that has debugger. So basically that has the Sager J-Link debugger, or it also allows you to flash devices that has the OpenDFU bootloader. In our case, this is we are not using this device. So I would just turn on the dongle, and maybe it will show it now. But if you see, this device is not in OpenDFU mode, so you cannot flash it. It can detect it, but you cannot. So we would press the button on the side to so that it goes to the OpenDFU bootloader mode, and then we would have to flash this with the hex file. That would be the remote coprocessor. So there are several ways you can do this. You can download already a hex file. I would not download a hex file. I would just create one and then flash it using this tool. So let's open Visual Studio Code. I already have some coprocessor application open from the last runs, but I will just close this, close folder, go to the NRF Connect plugin, and I will just create a new application. So this is basically, I just want to show you how you would do it. So I would do is I would just search for coprocessor, and there's Openthread coprocessor sample, and there are two. So there's a network coprocessor, which is I think the older way of doing things, and this is the newer way of doing things. Still maybe not the older way, but in this the thread coprocessor, I guess the dongle device that you have doesn't need a lot of CPU power, and the Linux machine is doing a lot of the heavy lifting. I can be wrong, but that's what I remember. So it's naming it underscore coprocessor underscore one because there's already a coprocessor directory, but for us it's fine. So we just open this, and then we would just do the standard workflow. So we would do add build configuration. Let's see. Okay, so it's doing some stuff, and our target device is NRF 52840 dongle, and just we do build. So it will just build the application for us. Let's just wait for it, and it will do most of the heavy lifting for us. So that's the nice part about using NRF Connect, is that it hides a lot of the details that you would do in Zephyr. In coming videos, I will show you how to work with Zephyr as well. This is just for beginners. This is much more friendly, and yeah, so now it's compiling or linking rather. Okay, so it's being done, but we cannot use this flasher because this flasher only works with devices that has debugger and JTAG or something like that. So with OpenDFU, I don't think this would work. If you select, so if you look at our connected devices, we only see one device. And if I say flash here, it would just flash this device. So I would not do this. It would have been nice if we had the option to flash the dongle also from here, but I guess in the future it might come. So currently this firmware has been built, and we need the hex file for this. So there are, to locate the hex file for this firmware, you go to the build directory, then there is the name of the application, and in here you would have something like Zephyr directory, and in the Zephyr directory then you have this zephyr.hex file. So this is what you need. So I will just close this and select a device that we want to flash, add a file. I would go to the file, and it's in our home directory. Okay, so then the coprocessor 1, then coprocessor 1, then Zephyr, and then this zephyr.hex file. And you see here, it shows you the different regions that you have. bootloaders and different stuff, but I don't know. For us now, what's important is that, yeah, let's just flash it. So now our dongle is flashed. If I go to here and close out of this application, if I go here, demessage and enter my password. So demessage basically gives you the kernel logs, and here in the kernel logs you can see that our device has been booted. So the thread coprocessor has booted. It has the serial number and everything, but this is the important information for us. So it is on TTY ACM0. That's where it is. So TTY ACM, there are probably more than one. So this is the ACM0. The ACM1 is probably our development kit that is running the CLI. This is the important part. So TTY ACM0 is our RCP device, or this thread coprocessor. So let's exit out of here. So our dongle is prepared. Now we prepare our Linux machine. So what you need is, since we are going to be using Docker based workflow, so you need Docker installed, and yeah, you should be able to use it without sudo. If you have to use it with sudo, then just follow these commands and just use sudo with them. So what we need is this Openthread OTBR latest. But the important part is that you need this IP6 table filter. I probably have it. If so, this is a, you can say it is a kernel module. So this is something that is run in kernel space inside the Linux kernel, and this is like a driver or something, part of a kernel that you can load at runtime. So in Linux kernel there are parts that comes pre-installed in the kernel, and there are parts that you can load later as well. And when you are compiling your Linux, you can also decide which one you want in the kernel and which one you just want to load later. So let's do lsmod, and then we pipe that into grep. So we pipe that into IP6 table. So we do so if I do lsmod, it will give you a list of all the modules that are loaded. And if I do grep, then from this output it should give us only the lines that has this IP6 table. So let's enter, and as you see here, this one I already have it loaded. In your case you wouldn't have it, so what you would need to do is, I would do it again because it doesn't break it. It doesn't do anything if you do it multiple times. So sudo modprof IP6 table, and then filter. Okay, modprof IP6 table, filter, right? And then usually, if after this, I suggest you do the check a demessage, and if there was some errors or something, that driver would fail to load, and it would print some error messages here. Since the driver is running in kernel mode, then the demessage should have those logs. So in this case, it didn't print anything, and if you know, in Linux world, if the output is nothing, that means success. So if it's return 0, it means success. So let's look at the lsmod again, and here we have this thing, or basically our driver or our module is loaded, and you can also check which other drivers are using it. So IP6 tables is using it, xtables is using it. So just some additional information for you. But basically, after you load it, you issue this command to ensure that you have this module loaded. And then I say run your final command. The final command is basically what you would have. You find it here. It's a long command, so you go to this link. So this is the Openthread documentation. It shows you how to set up, and basically if you go to get started, here it can give you some information about build and configuration, OTBR. This is just for Linux, but what this is doing is basically compiling the Openthread from source and doing all that stuff. What we need is, we don't need this. We want to just run it using Docker. And if you do it using Docker, then here this is the command that we just ran. And after, if you follow this guide, it shows you how to install Docker as well. So here we just ran this command, and this is for Raspberry Pi, this is for general Linux, and here you also have to do this command, so it's the same. And then you run this OTBR Docker. So this is actually the command that you have to run. And so basically we copy this command, and we go full screen, paste it here, and then we go through this command. So basically here are some system control parameters. I don't know too much about this. I'm just using them because I found them in that document. I think I read somewhere that you can use if you use the host mode in the Docker, then you don't need to have all this part. But with me it was not working, so I don't know, maybe something else was wrong. But just this command is how it is. And basically what it does is it runs your this OTBR image or OTBR Docker image, and pass these configuration, do the port forwarding. So the port 80 of the Docker image is connected to the port 8080 of your machine, and that means the web browser, you would be able to access it here, and gives it a DNS option. And then this is the important part. So it mounts the serial device, the RCP device of your machine, to the container, so the container is able to access it here. I don't know which side is the machine and which side is the container, but just make sure these are correct. And then here you have this as well, some additional parameter. So just make sure that these are correct. In our case, TTY ACM0 is correct. Yeah, so let's run this and see how it works. If it works, sometimes it can be a bit clumsy, so you might have to turn off your dongle, turn it on again, and run the commands. Or it's not very nice and stable. Sometimes it stops working in the middle. So let's see. So now we have it seems that it is running. So let's go to the browser, and let's go to the localhost 8080. So that's what we have. Okay, so we have our browser. So this is basically the browser interface to the Openthread border router. And so if you go to status, it's disabled. If we go to form, here you can basically create a network, basically how we were doing it with the OT CLI. So how you create a network, so here you can do that. And so I guess the easiest way is to create a network using the CLI, then use the join functionality to join it from here. So let's do that. So we would open the Visual Studio Code again, because that's the easiest way to go to the UART of the device 1. So let's go to the connected devices. It loads. So we connect with it from here. So it says connected now. So we do check the active data set. So we do have an active data set. So let's just do ot ifconfig up and then ot thread start, and then we check the state, ot state. So it's currently detached, then detached, still detached, should become a leader at some point. We issue the clear command as well. It's nice. Okay, so now it's basically active. And if you look at OT IP address, you got your IP addresses as well. We don't need that now. What we need is OT dataset active, and what we need is this network key. So now we go to the browser, we go to join, and here it will do a search. It will scan, and it discovered a network. So the PAN ID, wrong tab. Okay, so the PAN ID is this is the extended one, 0xD416, XD416, channel 11. So the scan is basically scanning all the channels, and then basically hardware address is what. And so let's join that network. So here it would ask you credential type. So our credential is network key. This is the default key used in a lot of examples, but since our key is different, we just copy it and use it here. This prefix is used for routing. We would talk about a bit more about this in details in coming videos. So let's join. Okay, so join operation is successful. So let's go to the topology now, and this should show us the two devices. Sometimes it can take a while. So let's see if it loads. Yep, it is taking its time. Yeah, you can refresh it. It will still take its time. We would just leave it here for now. So what do we have here now? Let's check the IP addresses again to see if there's something new here. So we have FD178, this one, this one, this one. So these are basically these three guys. Then we have this FE80, and we have these two new addresses. Basically these are coming from the router. Do the test now. So what we want to do is we want to ping 8.8.8.8. So what it's doing is it is pinging. It pinged it, one packet transmitted, one packet received, packet class 0. And what it did is it basically, this is IP version 4 address, so it translated it into a format that is IP version 6. Basically our machine formatted that, and this is something called NAT64, so network address translation 64. And once then it sends a, basically our node sends a packet ping to this device, and then the border router knows how to decode this into this. So it's doing the translation, and then it translates it back as well. So this is how it works. And you can also send UDP commands. We don't have a UDP listener yet, so in the next video I will just write some Python script that would work as a UDP listener, and then we would send some UDP packets from here and try to sniff that using Wireshark as well. Thank you very much for watching, and see you in the next one.